Good evening and welcome to Y 2025. This is 10th Andromeda. It's day 3 evening, and we're talking about a topic that's very close to my heart. Probably not to yours, but our speaker is going to change that. We're talking about mail servers, we're talking about security, DNS, etc. But I won't want to spoil you all topics of the talk, so please welcome with a very warm round of applause your own Mail Server 2025 edition with Simon Micro.
Yes, thank you. So, this is my first time on a big stage. Last time I was in Casablanca, so yeah, this screen is really nice. I'm Simon Micro. I like to tinker with software and hardware, both in my job as well as in my hobby. I'm part of the Karlsruhe Osnabrück and also available here as the DKIM and doing networking stuff. And yeah, of course, this isn't really relevant for mail servers. But mail today. I've seen a lot of mistakes over the time, and also, of course, I did my fair share of them on my own. I embedded all those thingies into this presentation. I hope you learned something from it. At least, well, the speaker is stupid and did some stuff. All right, so yeah, I have my own home lab since 2021, and this is the location where I did all this bullshit. So let's dive in and figure out what I did with this talk. Yeah. Also, small disclaimer beforehand, this talk is targeted at more email beginners, so I try to not go as much into technical detail, but I know myself, so let's try to be on time. So, email 101. Really quick overview about how does email work. In the middle, we have our server, here symbolized with a disk. This is a server somewhere on the internet, hopefully not hosted by a central provider or Microsoft or Gmail, whatever. It is somewhere. This mail server is using a protocol called SMTP to actually submit the emails you're sending to other providers, other mail servers, to exchange information as well as receive them. The mail server then can be accessed over protocols like IMAP or POP3 by your usual clients, be it smartphone, be it your laptop, be it your web interface, to actually retrieve the emails so you can read them. I mean, yeah, can be Thunderbird, can be Fairmail, whatever you want to do. Those are just using this IMAP protocol, hopefully, to interface with your mail server. So, SMTP. What is going on with this? So SMTP is, as I say, it's important for sending and receiving the email itself. It is most of the time implemented by different softwares, and so softwares can differ in their complexity, their compatibility, and how they're being configured. In our case, I'm just listing a few software I have laying around. SendMail, XM, Postfix. It really depends on how much you want to express or how many details you want to include in your configuration language. So it can be arbitrarily complex, and the more you go down this list, the more messy it gets. Besides also just sending and receiving, you can also just send emails. This is really important for servers if you want to get status notifications or local system messages. For example, somebody tried to enter a pseudo password without actual authorization. You can use something like OpenSMTP or NullMailer. Those tools are just living on your server, building up a queue and trying to submit it as fast as possible against the real mail server, which is actually able to receive these emails. And hopefully has a public IP and a good reputation and can be actually used. So, yeah, those thingies, receiving emails, also have a lot more complexity going on. Not only the way of being configured, but also, of course, the way how they can interface with other languages, or not languages, but also with other tools. For example, Milter is a common concept shared by multiple of those to interface, for example, with spam detection or even other scripting. There's an upcoming protocol called, not upcoming protocol, but the language sieve you can use to write your own rules is also now becoming available using managed sieve, which is a separate protocol to manage those files. So it can hopefully be at some point independent of web interfaces. Not implemented anywhere, but whatever. So, sending only. Basic routing rewrites. There isn't much going on because you just submit an email to this small local daemon and it's uploading it to the cloud, and that's basically it. Okay, regardless, there is still some stuff to be kept in mind, because your different programs I've listed here are not all supporting the same way of implementing some kind of a secure transmission layer, or actually verifying the identities they're submitting their emails to. And if they do, this really depends on the configuration language. I'm looking at you, XM. It is an absolute nightmare to configure like a satellite server with it, because it cannot really read-write from header fields, which is used to communicate from which the email originates, which is a nightmare to implement. Whatever. So sending only, use those tools if you really want to just send emails and not receive them. OK, so receiving emails on this topic, or retrieving in the sense, let's take a look at IMAP. IMAP, there's a program for it, Dovecot. And that's basically it. There isn't much diversity going on in this field. Of course, there is your favorite program also available, but really implemented is, or really popular is just Dovecot. It is highly popular and included in many other implication bundles, and also likely available on your own distribution, so just go with it. There's also fetch mail available. For example, if you have an email inbox already at another provider, you can use this tool to fetch them down into your own inbox. I don't know, it is sometimes pretty useful. Yeah, where's POP? Yeah, it's not really popular. Turns out POP, if you enable the option to still keep the emails on your server, isn't really popular, isn't providing any advantage in comparison to IMAP, because you can just still access folders and download the emails the same way IMAP does. So, yeah. So I've now talked about a few protocols, SMTP, IMAP, but there's a lot more going on with email servers. So let's take a look at all-in-one solutions. Those are commonly coming in some kind of mega package where everything is being implemented at once. Just listing a few application fields here. It highly depends on the one you choose in the end, but I really recommend you to play around with it. Set up your own mail server and really get started with all-in-one solutions, because you do not need to understand all the different services running in the backend to get started. And, well, sending the first emails until we reject it. So, yeah, I don't know. Those are just all the things the all-in-one packages use. And so, yeah, get faster started with. Most of them are using some kind of distribution system like Docker, which is independent from the actual operating system, because they are needing to bundle so many different applications and provide their own isolation level. This has some advantages, like easier maintenance, but also makes modification and modifying those all-in-one packages in non-intended ways much more harder. I mean, this is a classic trade-off, but something you should keep in mind if you're reading some random guy his post on Stack Overflow and trying to implement it. With all-in-one solutions, you will likely run into issues if you're trying to do this. You, in those cases, have to actually understand if you want to go beyond the administrative panel. Yeah, and also you can break a lot of things with all-in-one packages, and those updates also may change configuration in an unintended way. One of those packages I would, on the other hand, really recommend you is to get started with something like MailCow. It, once again, uses popular software like Postfix or Dovecot to actually provide the email functionality, and is quite well made here. Like, we have good documentation, we have a well-designed administrative panel, and, well, all the implemented features actually work. On the contrary, there's MailU. No rant, but MailU is also software I'm using on my own. It was created around the same time, but it has many problems where, like, some APIs are not well implemented, the UI is a little bit clunky, and it is becoming less popular nowadays. But it is still a valid choice if you just want to get started with mail servers. And because MailU doesn't have that many features in comparison to MailCow, you can more play around with it and dive a little bit deeper. So, yeah, and also, if you really want to do it on your own, there's a really nice guy in the internet who wrote over the span of 5 years a blog series, how to get started with mail servers. So if you really want to go into detail and actually understand what was going on, you should check his blog out and search for the post. I didn't put in the link here because it would be way too long. OK, so all-in-one solutions. And a not working laptop, nice. We also can now start focusing on SMTP. I had this trouble before, give me a minute. OK, so aggressive clicking it does. Here we go with SMTP. I'm now going to focus a little bit more on SMTP because it is a primary way of exchanging messages between mail servers. But there's also a little bit more with it. You all know it, spam. It is in the internet, always there, and you always get junk emails. And SMTP is primarily responsible because it is communicating those emails. And one of the goals of today is to give you a few tools at your hand so you can improve your spam score and try to hopefully not land in the junk folder of the partner you want to reach. Also, you can hopefully increase the trustworthiness into your own email server if we get those things right, we are now coming to, because then you can hopefully be sure to actually reach the other side. I had my fair share of problems with that. SMTP has really few mechanisms embedded directly into the protocol itself to ensure that the party you're trying to reach is actually the party you are currently contacting and communicating with. And the tools we are now taking a look at are patching those things in. Well, security has an afterthought, so we always have this problem, like these are just some tools developed in the early 90s and they are more or less working. Yeah. And also we have another problem with SMTP. If we are trying to submit an email, we're not only sure which party we are trying to send the email to, but as well as is the sending or submitting party even the party who should be sending for the server? Okay, so, this shouldn't be visible. DMARC. DMARC is also out there to help you in case of SMTP issues. It allows you to record and as specified in this RFC, the submission of your emails to another party. So if you've now set up your home server and installed some of these nice all-in-one packages, but you're not sure whether you're actually reaching anybody, you can enable DMARC to ask the other party to please send you a report at the end of the day, whether your email was rejected due to whatever. It is just a DNS text record, like, wow, mail, DNS. This is a connection we will make a lot this evening. And in the end, we do not need to talk about all the details right now, but in the end, you're receiving an email at your own mail server, hopefully if it's configured correctly, about the submission state of the different messages you've sent before. Also, if you want to observe something, there are ARC headers. If you want to take a look at them, just open your email, click View Source, and there are different headers available which describe why your mail server accepted the email, from which it was originating, and why was it accepted in the first place. So it's also really nice to figure out why specific mail servers didn't submit an email, or where is spam actually originating from, so you can create your own active countermeasures, which should already be implemented by your choice of all-in-one packages, but sometimes really clearly and badly failing. So yeah, we're talking about DNS for some kind of security, or at least in this case observability. This isn't really nice. So many all-in-one packages started to implement actually DNSSEC. So they're using signed records. This will also be a problem for you, because if you're using something like a Fritzbox or something, so an ISP-provided modem, they are maybe not properly implementing the DNSSEC extensions for DNS to work. So your mail server at home may throw in additional errors. It may even actually outright refuse to work in the case of MailU if DNSSEC isn't properly set up. So, DNSSEC, security. Let's talk about actually securing SMTP. And one of the first steps is enabling SPF. SPF is a way of making sure that the sending party's peer's IP is actually allowed to submit emails for your domain. And this is interestingly something which many people enable, but do not quite get right. So let's take a look into such a record, like, yeah, once again, an RFC if you want to look at it. You have different segments of such a record. It is once again just a DNS TXT record you submit against your DNS provider, and it allows the receiving party to verify whether the actual sending IP address is the one allowed to send, as stated before. There's different segments of this DNS record which may mess up, because this is the whitelist. Everything you do not include here isn't allowed to send, which is the actual design. But if you're using any kind of, for example, third-party email submission systems, because your private IP is maybe not allowed to submit against Microsoft, you run into the problems that you may not know all the other IP addresses of your sending party, which you are now indirectly using because you're using, for example, a satellite system to submit the emails. You can try to circumvent this by using include, but even then you may run into troubles where the third-party provider doesn't properly disclose all the different IP addresses because they're for itself using a third party. And in the end, you're instantly using Google, which is a really, really big IP address block to whitelist and even shared servers. So if you want to use this, be careful with it. And for example, at the start, do not use -all because this would not only just remove the emails, but actually not quarantine it, but remove the emails. So I was a little bit confused. Yeah. As I said, be careful with third-party transmission agents. DKIM. DKIM is another way. In this case, we're requesting our own or requiring all the sending parties' email servers, so our servers, to also sign the emails. You now have to create a private and public key pair on your servers and publish the public part. And once again, guess what? DNS text record. In those cases, you encode the key in there, for example, base64 string or whatever. You have to put in the whole key, so it cannot be a long key, so don't use more longer RSA keys. And this basically forces, if I receive an email from you, I will look up this record and actually test the signature of the headers. This isn't the signature also spanning, for example, the attachments, it's just for the headers itself. Yeah. Also, we run into another problem. Once again, if you were trying to use a third-party submission service, once again, for example, because you have a private IP, you are required to provide a unique DNS key identifier for the thingy to work. If you want to take a look at it, once again, please take a look into the RFC. But this basically means if you enable this, you're likely to shoot yourself into the foot because you either don't know the public keys IP, public key values of the other parties, or cannot list all. And even then, they may be choosing the same key identifier name as you did for your own mail server, or as another party did. In this case, you're running especially into trouble with all-in-one solutions because they're just pre-configured and you cannot change it that easily. So yeah, please enable it, but this also likes to break stuff. All right, continuing, DANE or TLSA. This protocol extension doesn't gain much popularity yet and is still missing a lot of implementations. But yeah, what is it before we're starting off? Basically, once again, we are requesting a signature which is matching. But in those cases, we are matching against the SSL certificate of the server itself. It is basically a way of pinning the certificate of a service to the actual implementation or identity of the server. In short, if you use this with DNS, you're also pretty easily able to lock yourself out of the server for multiple days because those records are getting cached pretty aggressively. Those are more or less specified in those two RFCs and are now also living in DNS, but now are being implemented using a special record type. This special record type is once again not really expressed by using a TXT, but instead we're now having different fields we need to implement. Those fields are having some kind of integer, and you need to answer those questions correctly. If you get it right, you will break stuff. I don't know how well you understand the TLS architecture, but to answer those questions, you need to be very familiar with the way how you obtain certificates. In case you're using some free services, for example, Let's Encrypt, this means you have to understand how the certificate chain of Let's Encrypt works, which is well, because you now learn something about SSL. But on the other side, it gets pretty complicated if you want to renew these entries periodically. If you trust just your whole CA, you run into issues where the CA may roll its own certificates. So once again, you can try to do this in your home lab, but you're also likely to break stuff. And this is especially really bad because the implementation for those extensions isn't good. So if you're, for example, submitting an email against another server, they may not actually check those records. And on the other hand, well, many protocols are covered, but the monitoring is really hard. I've not yet seen any HTTP tool to properly check against the TLSA extensions in DNS. For example, iUptime Kumor or black box monitoring isn't properly working with this. So if it breaks indirectly, and it will break a few providers, and you will be struggling for weeks to find out what did you wrong. So maybe you shouldn't do this, except if you like security. So yeah, SMTP ports. There's also a little bit to think about. SMTP is quite old, so security was all thought afterwards. They built different extensions, and one of those extensions targets the way how the security or how the communication over the different ports is being performed. Starting off with port 25, you're just using plain ports, nothing special. Your client now can send a command called start TLS, after which the server is required to just open a TLS extension within the socket and communicate securely by providing a certificate. You have to check it, and now we are talking over an encrypted session. There's another port, 465, just ignore it. It's SSL only. It is the one before TLS, so just don't use it. It is more for backward compatibility. And then we have 587, which is basically, if your client connects, he has to instantly speak TLS. And this is a port we actually want to talk about, or communicate about, because it's an actual secure implementation. Start TLS has many flaws. For example, clients can upgrade to TLS. They are not required. So even if you tell your client to please connect over 25 and use Start TLS, they may choose to not. The servers can be spoofed, man-in-the-middle attacks are possible. So Start TLS isn't like a secure way to do it, and just exposing port 25 maybe presents other things. So how about we block port 25? Interesting story. This is bad, because now people cannot tell you you've got a broken TLS system, because they cannot reach you anymore. And also, some services are implementing only port 25 with mandatory start TLS. This is something really interesting I stumbled upon with a financial institute in Germany, where they're submitting emails explicitly only over 25 with start TLS, and not actually using TLS, which is bad, because it potentially includes financial information. But whatever. So, coming to the closing section of this random talk about different SMTP aspects, or mail server aspects in the broader sense. Yeah, test your mail server, by the way, and test your slides. First point, please implement additional security measures. All these extensions I've shown you today into DNS aren't enough on their own. You should consider, for example, blocking IMAP access to the emails itself within your network, especially if you're just doing your home lab. Nobody else will read your emails, or should be able to access your emails residing on the server, so just block IMAP at all. Furthermore, do reputation-based IP filtering. There are some other services out there. I would personally recommend something like CrowdSec, but please feel around to explore other options. They're just doing reputation-based IP filtering in the sense of they're providing honeypots, and if other bad guys are submitting emails, they're getting catched there. So this is already a way to significantly reduce your spam in your email networks and increase your email server reputation. Also, there is something out there called brand indication for message identification. It is like a pre-RFC stuff. Some random clients are supporting it, and if you read through some security instructions, you will find recommendations to enable it, which is mostly just marketing stuff. Yeah, it just adds a nice picture to it. Yeah, in the end, test your mail server. There are tools out there. There are also stuff you should keep in mind when working with clients, for example, end-to-end encryption, which is just plain old better than working over the insecure mail server network. And nevertheless, I think we are now coming to close due to time restrictions. I hope you've learned at least something and are now trying to set up your own mail server in a more or less secure way. All right, thank you very much. You can reach me down there, and yeah, I think that's it.
Thank you very much for that speed run around DNS and some email stuff as well. We might have time for one or two quick questions if you want to. Please.
Hello. Yes.
Hello.
What do you think of Stalwart? It's a Rust implementation, all-in-one application. Seems really nice.
I have seen it, but I have not used it yet because it was a new implementation and I haven't seen a lot of users adapting it yet.
Hi, thanks for the talk. Do you have any recommendations for resources regarding ASPMD? Because I host my own email server, but I got a problem. It has ASPMD, but I still get a lot of spam. So do you have any resources?
RFC, sorry, I didn't get this keyword. In those cases, I would actually recommend you to look up those all-in-one solutions, jump into their GitHub, and they're often providing some kind of configuration folder for RFC-restrictions, which they are just copy and pasting in. This is a great way to start and just adopt a more or less matching setup right from the start up.
Okay, thank you.
And on that bombshell, I have to end this talk, unfortunately. Please give another round of applause to Simon Micro.